Today in the workshop, we're building an ESP32-CAM Developers Module. I'll show you how this simple project can simplify working with the ESP32-CAM. It even has a built-in portable power supply that you can use for all types of experiments. We're making things easy today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we're going to be building a project. We're going to be building this thing that I'll show you in greater detail in a few moments. Now, what is this thing, you might ask? Well, you might not ask because you probably saw the title of the video. This is a development module for working with the ESP32-CAM, and this project sort of came about out of necessity. I was starting to film another video for you folks on the ESP32-CAM, and I'm going to be doing a lot of videos on this device because I'm working with a lot of IoT devices right now, and I think the ESP32-CAM is almost the perfect IoT project device. And I was starting to set up to do my video that I was going to do for you and that I will be doing for you, and I found it a little bit awkward working with the ESP32-CAM. It's not that difficult, but there are some issues with the device that make it a little harder to work with than, let's say, an Arduino Uno. For one thing, it's got components mounted on both sides of the board in order to make the module so small. And one of the things on the bottom side of the board is the reset switch, and you need to get access to that switch when you're programming it. You also need to get access to it when you're running the programs. And the only way to get access to that switch, if you have it on a solderless breadboard, is to mount the device at the very end of the breadboard and use something like a small screwdriver to get in at the switch. It's a little awkward, but you can do it. Another thing, though, that you need to do when you're programming is that you need to add an external FTDI adapter. The ESP32-CAM, unlike many other ESP32 modules, does not have an internal USB port. And so you need to add that device, and when you're programming, you also need to tie GPIO 0 down to the ground. Another thing about programming this device and working with it in my IoT applications is that many times after I get it working on the workbench, I want to test it out in the location it's actually going to go, and that could be a remote section of my home. And that being the case, having a portable power supply for the ESP32-CAM is a very useful thing. So I've combined a lot of features into this little device in order to get around a lot of those problems, the problem of getting access to the reset switch and of using the FTDI adapter, etc., etc. So I wanted to show you today how I built this device. Now, you may indeed want to build a similar device. If you're working with the ESP32-CAM, this can really save a lot of time during development. But you might not have any interest in building this device. However, you may want to take the same principles and build another similar device for another microcontroller or another microcomputer. This box also has an internal power supply that I constructed that can give you 3.3 or 5 volts and can use an AC power adapter or an internal 9-volt battery. So that alone might make an interesting project. So let me show you this thing in detail, and then I will show you how I constructed it. Now, before I show you the ESP32-CAM development module that I constructed, I want to show you what the issue is with the ESP32-CAM that inspired me to do this in the first place. So I've got a couple of modules over here. Now, here is a typical ESP32-CAM module, as you can see, with the camera and the micro SD card on the front, and this big LED that can be used as a flash. And one of the issues is the location of the reset switch, which you need both in operation and programming, and it is right up at the corner over here. So that is the first issue. If you take this module and place it on a solderless breadboard, well, the first thing that you can see is that you've used up most of the breadboard pins. You're only going to get one pin over here to be able to connect to it. It's also eaten a lot of your breadboard up, but it won't work in the position I've got right now because you simply can't get at that reset switch. It's under here. Now, you can resolve this two ways. If you want to use a solderless breadboard, you can put it up at the end over here, and then you can kind of get at the switch if you use a screwdriver or something to press it. So that's one resolution. The other way you can do it is by connecting female to female jumper wires over here and connecting, or female to male ones that go to the board over there. You'll need a jumper wire as well between two of the pins, GPIO 0, which is down over here, and there's a ground pin right next to it. They need to be jumpered together while it's programming. So there's a lot of jumpering you'd have to do. You need to have the board loose with the other wires or on the solderless breadboard at the very end. And then remember, you've got a camera over here. So even if I do manage to mount it, let's say, on my breadboard, at the end of the day, I've got something that's facing my ceiling, so I've got to move my breadboard around in order to work with it. Now the problem gets even worse when you attach the external antenna. You remember I showed you how you can move the position of a small resistor and attach an external antenna for improved performance instead of using this printed circuit board antenna that you see over here. And I've done that to this module, and so you've got all the issues I just mentioned, and you've also got this antenna to deal with, which is a little bit difficult to manage sometimes. At any rate, it's not the world's worst problem, but it is certainly something that can be improved upon. And my feeling is that if you have to go through all these hassles in order to prototype with this, it might turn you off from actually working with it, and we wouldn't want that to happen. So let me show you now the solution that I came up for all of these issues. And so here it is, the fully assembled ESP32-CAM Development Module. And as you can see, of course, the main feature on the front is the ESP32-CAM itself and the external antenna that I've got mounted over here. And on the back, the main feature that you can see is the solderless breadboard. Now, the ESP32-CAM module itself actually just comes off like this. It's a separate entity, and it could be used on its own because basically all of the connections from the ESP32-CAM module have just been brought out to this female connector over here, and of course there's also a place to mount the external antenna. And you'll notice that I've got this at an angle. These aren't just going at a right angle. I bent the pins, and that's intentional, and that's so when I fit this back onto here, the camera is held at a slight angle upwards so it can get a better shot. Now I'll have to confess that there is a design flaw over here that I can easily correct by redoing the front module, and you'll see what that design flaw is in a few moments. Now at the back, of course, we have the solderless breadboard, and behind the solderless breadboard there is a row of female connectors, and these are for inserting wires into. And this is a row of connectors that mimics what's on here, and it has every single pin of the ESP32-CAM there. And then we have a row of male connectors, and they are exactly the same thing. So you could use another jumper wire with a female end, or you could use a ribbon cable or something to extend this off to another solderless breadboard. You could also use it as a test point for something like an oscilloscope or a logic probe, so you can test a point that you've already got wired up with the female connector. Now on the side over here, of course, you can see the FTDI adapter. I'm going to remove it and take it out of its socket right now, just so we can see this a little bit better. Now up in here you've got 3 terminals, and this is the 5 volts, the ground, and the 3.3 volts. And beside it, I'm hoping you can see that because it's kind of buried down here. Let me take the front module off. It's a little easier to see now. There are 3 more rows of the female connectors, and this again is the 5 volts, the ground, and 3.3 volts. So you can get at those for your experiments on the solderless breadboard. This connector, of course, is for the FTDI module. This jumper here has 2 positions, and it is the voltage that is going to be applied to the FTDI module or taken from the FTDI module, depending on what your voltage source is. So this can change it from the 3.3 to 5 volts and wire the FTDI module VCC to the 3.3 or 5 volt pins on the ESP32-CAM. Now this setting needs to match what you have set on your module. Now my module is a jumper. Some of these modules actually just have a solder bridge that you have have to make so it's more permanent. Normally you would set this to 3.3 volts for the ESP32-CAM, but some folks have reported better results by setting it to 5, so you just have to match this to that. This other jumper here is actually open right now. When it is closed in this position, it ties GPIO pin 0 to the ground, and you need to do that when you're programming the ESP32-CAM. Now this could also have been a switch, and in some ways it actually might be handier to have it as a switch, but right now it's just 2 DuPont pins that I can put a jumper over or put a jumper cable onto. Now you might notice at the bottom I've got a push button and I've got an LED. Now there are another row here of 4 female connectors. Now the bottom 2 just go to the 2 pins on the push button. It's a normally open single pole, single throw push button switch, and it just allows you to connect to the push button. The other 2 go to the LED through an 82 ohm dropping resistor. Now that may seem a little lower than what you're used to me using, but remember we're using 3.3 volt logic over here. The reason I've wired the push button and the LED up are simply because on most experiments with the ESP32-CAM, if I'm adding something external, it's going to be a push button or an LED. So by having them over here, I don't even need to bring components onto the breadboard. I could even just do my wiring from the ESP32 bus over to the LED or the push button, as the case may be. And that'll probably save me even more real estate in the Solderless breadboard if I have to put other components on there. Now, on the side over here, you can see 3 binding posts, and the 3 binding posts are for the power supply, of course, and this is 5 volts ground and 3.3 volts over here. This is the power switch. When this is turned over to the red side, this is actually powered up right now. Now there's no LED on here. I had thought of placing a power LED on it, and you could certainly do that. Since it's operating on batteries right now, it's actually on. It's actually providing power over here and providing power up over here to this board as well. And I just thought the LED would just consume a little extra current and may not be necessary, but you could certainly add one. This switch over here allows the power from the power supply to be applied to the module over here. By having it in this position, it's actually disconnected, so the FTDI module would be the thing supplying power to everything. But with that switch in this position, the power from the power supply is sent up this cable and applied to everything here. So you can power things 2 ways. You can also get at the power through these 3 terminals, as I mentioned. So you could also have an external power supply feed that. So it's quite versatile as far as power supplies go. And speaking of power supplies, on the side over here is a jack that you can use for a 9 to 12 volt adapter instead of using the internal battery. And as soon as you plug the jack in, it cuts out the internal battery. It doesn't make any attempt to recharge it or anything. But there you go. We'll put the top back onto it again. And we have our completed ESP32-CAM Development Module. Alright, now that we've seen our little experimenter's module, it's time to actually construct it. Now, I constructed my module using perf board, and I also used a small plastic case. And all of these components were things that I happened to have around my workshop, and none of them are particularly critical. So you could build a similar device using different components, and I'm sure it'll come out just fine. So let's go and take a look at the construction of our ESP32 development module. Now here are some of the components as well as a few of the tools that I used to assemble the experimenter's module. Now the main construction is done on 2 pieces of perf board. There's a small piece of perf board over here that I used for the ESP32-CAM itself and the antenna, and this is a 3 by 7 centimeter piece of perf board. And these are very nice perf boards that you can get on Amazon or eBay. They're plated through and everything. They're very high quality. This is a 5 by 7 version of the same type of perf board, and I use that for the base that has the Solderless breadboard on it. Now you don't have to use the exact same sizes that I did. You might want to expand and use a bigger one for the base and put maybe a larger breadboard, or maybe more LEDs and push buttons on it if you wish. Over here, of course, we have the ESP32-CAM, which it goes without saying we need. An FTDI module. You don't have to use the same one I did. Be aware some of them have the components on the other side and are thus mounted in reverse, but they have the same pinouts otherwise. With the Solderless breadboard, naturally, with the adhesive back. This is a 3-pin terminal strip that's going to be used for the power connection. It's on a 0.2 inch of a grid. It's a very common terminal strip, but you can use a different connector or terminal strip if you wish. That's not critical. Here is the LED. It's a 3mm red LED. I would recommend staying with red LEDs just because they have the lowest forward voltage drop, and we are using 3.3 volt logic. You could use a bigger one though. You could use a 5mm LED if you wanted to. This is an 82 ohm dropping resistor for the LED. Again, the value is chosen because of the fact that I'm using 3.3 volt logic and not 5 volt logic. You could play with the value, but I wouldn't go below 52 ohms, and anything above 150 ohms will probably make the LED too dim to really be useful. Now here's a pretty standard PCB mount push button switch. It's got 4 pins on it, but there's really only 2 connections. In each case, 2 of the pins are duplicated. And here's some headers that we're going to need for the jumpers. You probably have a few of these lying around. If not, again, Amazon and eBay are great resources for that. Now these are female header strips, and they are going to be used extensively in our wiring. You're going to need at least 2 of these to complete it, and you can use a set of diagonal cutters like this in order to cut these down to the size that you want. Now be aware when you do that, you're going to end up sacrificing one of the pins, but that's just the way it goes. You can also use the diagonal cutters on these male header strips, and you don't end up sacrificing any pins because there's a notch in between each one. One of these strips will probably be enough, although I've shown 2 over here. And this is a right angled header strip that you're going to need to construct this. I also used a few pieces of this down in the power supply construction that you're going to see later, but this is what holds the front board on. And I also ended up, after clipping it down to 16 pins, which is what we need, I held one end in a vise and I used some pliers to lift up the other end. Now I did the bulk of the wiring with this using wire wrap wire. I'm not sure if you're familiar with wire wrap wire, because wire wrapping is a virtually extinct technique from the 1970s that we used in order to wire up perf boards without actually soldering. And although the technique is kind of dead, the wire is fantastic and is very easily found on eBay and also on Amazon. Wire wrap wire is 30 gauge wire, so you'll need a stripper that can handle it, and this can handle 30 gauge wire. It also goes down to 20 on the other end, which is convenient because I also used 20 gauge wire as well for some of my power connections here. So I used both 20 gauge and 30 gauge wire for the connections, and the 30 gauge wire is actually very easy to work with. You might think it's kind of small, but really it's not that hard to work with at all. And of course, a pair of needle nose pliers is essential for doing this kind of wiring and wrapping everything. And naturally you're going to need a soldering iron, some solder, and all the various equipment like that as well. An electric drill to drill the holes that you're going to need for the antenna mount, and also you're going to want to enlarge the holes that this terminal mounts into as well on this board. And you'll need a drill when we come to the chassis for the power supply unit. So there you go, a lot of the components that we'll need to get together. None of them are really critical except of course the ESP32-CAM. So you can substitute a lot of stuff you probably have in your own workshop, and I'm sure it'll work just fine. The first section we're going to wire is the front module, which is fairly straightforward. We will need an ESP32-CAM module, which we will mount on 2 8-pin female headers. You can cut these headers from a larger header. I'm not showing the external antenna connection. You may add it if you wish, and you should provide a mounting hole for the antenna on your module. You'll also need an additional 16-pin female header that's mounted on the other side of the perf board or printed circuit board that you're using. The two 8-pin female headers holding the ESP32-CAM are connected pin for pin to the 16-pin female header, and this completes the wiring of the front module. The main board can be wired in sections to make it easier. We'll start with the 90-degree 16-pin male header. This is the mate for the header on the camera module board. I bent mine so it wasn't 90 degrees using a large pair of needle nose pliers and my bench vise. This way the camera is propped up a little bit better. On the other side of the board we have two GPIO breakout connectors, a female and male DuPont header, each of them 16 pins. We need a 3-pin screw terminal for a power connection. We also need three 3-pin female headers, one of them for 5 volts, one for ground, and one for the 3.3 volt connection. The power is also connected to a 3-pin male header. This is the power connection from the onboard power supply. 2 more male headers are also required for jumpers, a 2-pin one for the programming jumper and a 3-pin one for the FTDI voltage select jumper. A 6-pin female header is used for the FTDI adapter connection. A 4-pin female header is used for the push button and LED connections. We'll also need a PCB mount push button, an LED, and a dropping resistor for the LED. I used 82 ohms, but any value from 56 to 150 ohms will work. We'll begin by wiring the power section. I used heavier wire for this section. It's a good idea to do that to allow for a higher current draw. Start by hooking up the 5-volt connection from the 16-pin header to the 5-volt terminal and female headers. The 5-volt connection is also run to the 3-pin external power input header and to one side of the 3-pin FTDI voltage select jumper. You'll find several ground connections on the 16-pin ESP32-CAM GPIO bus. I used the one right next to the 5-volt lead to make a ground connection to the center terminal of the screw terminal block and to the female DuPont headers used for ground connections. Another ground connection is made to the center pin of the 3-pin external power connector. We will also connect the ground to the FTDI connector ground pin, which is on one end of the connector. The final power connection from the ESP32-CAM GPIO is the 3.3 volt line. This is connected to the 3.3 volt terminal and female headers. We also run the 3.3 volt line to the external power connector. And we complete the 3.3 volt wiring by connecting it to the line on the other end of the FTDI voltage select jumper. We connect the remaining center pin of the FTDI voltage select jumper to the VCC pin on the FTDI connector. This pin is separated from the ground pin by the CTS or clear to send pin, which we are not using in this design. Now for the FTDI data connections to the ESP32-CAM. We start by connecting the UOR or receive pin on the ESP32-CAM GPIO to the FTDI adapter TX or transmit pin. Remember, the FTDI transmit goes to the ESP32-CAM receive and vice versa. The FTDI adapter TX pin is right next to the VCC pin we wired in the last step. In the same fashion, we connect the ESP32-CAM UOT or transmit pin to the FTDI adapter RX or receive pin. On both the GPIO and the FTDI adapter, these pins are next door to one another. Now let's hook up the programming jumper. This is the jumper that needs to be closed when you're uploading code to the microcontroller. One side of this 2-pin male header is connected to the ESP32-CAM GPIO pin IO0. The other side of the programming jumper is connected to ground, and any ground on the GPIO will work. Now we'll move on to the LED and push button connector, which is a 4-pin female header. Connect the LED plus pin to one side of the 82 ohm resistor, and then connect the other side of the resistor to the LED anode, which is the longer lead on the LED. Connect the LED minus pin to the LED cathode. Finally, connect the PB1 and PB2 pins to 2 pins of the push button switch, making sure to select the correct 2 pins. Use an ohm meter if you're not sure about the push button pinouts, and solder all the pins, including the 2 unused ones, to the board to secure the switch down. To finish all the wiring, connect all 16 connections from the male 90-degree header to the female and male DuPont connectors, pin for pin. And this completes the module wiring. So now that you've seen the wiring diagram, I want to show you how I wired everything up. Now the first thing is the front module, and it's a fairly simple wiring job because it's basically a straightforward connection pin for pin of the 2 connectors over here to the one there. Now the only difficulty that you might have, of course, is the fact that 2 of these connectors are mounted facing this direction and 2 are mounted on the opposite side. So what I did is I first made all of my connections over here to the 2 female connectors that are going to hold the ESP32-CAM, and I fed the wire through the hole above this connector over here. I didn't have the connector here at the time. I fed the wire through the breadboard hole, brought it out to the end, cut it and stripped it so it was the right length, and then I inserted this, which is a 16-pin female connector, and I inserted that on this side over here, and then this did the soldering job. Now this is a wire wrap wire. It's 40 gauge wire, so it fits very nicely through the holes. If you're using larger wire and it won't go through, you could always strip the insulation before you go through the hole and just have it go bare through here and there, and that would also work very well. And there's also a hole drilled here, of course, for the antenna on this. Now the ESP32-CAM is just going to fit onto its connectors over here, onto the 2 female ones, and since that lifts it up so high, it's very easy to get at this reset switch over here now, which is nice. And then this just feeds out the back over here, and as you can see, there's some nuts on here that I could screw it onto and then put the antenna there. So that completes that front module. Now this is the main module over here, the base module, and it's fairly easy to wire as well. What I would recommend you do, you'll notice I used some heavier gauge wire as well as the wire wrap wire. This is 20 gauge wire, and I use this basically everywhere that I had a power or a ground connection to make. And I just do that because it has to carry a little bit more current, so I wanted to use a higher gauge wire, but you could probably get away with the 40 gauge wire for everything. I would recommend wiring everything up in this section over here, the FTDI adapter, the power supply connections, the 2 jumpers, the connections to the LED, and the push button switch. Get that all wired up and get your connections made, and also I made all of those connections to this front connector over here. So I made those connections first, and then at the end of it I just simply took wires and went back one by one, all 16 connections. On the end over here I got to the female connector and then just made a very, very long strip of the insulation and jumpered it over there, so there's no insulation on the wire between the 2 connectors. And I'm not sure how well you can see the connection because it's thin wire and there's a pad underneath it, but trust me, every one of these is connected. Now, of course, when you work with this stuff, what's important to do is, as you're going through, use your multimeter and make certain that all your connections are going. It's a very easy one to buzz out because it's literally 16 pins that connect through to here, and then a couple of connections here, of course, for power, ground, and 3.3 volts over here, and the FTDI connections. So you can buzz all that out with a meter, the same with the ones over here, and you can be pretty confident it's going to work. One final thing is this connector over here. This is on a 0.2 inch grid, so it goes every second hole, but the pins are too large, at least for this type of solderless breadboard, so you'll need a small drill bit to enlarge the size of the holes for this one over here before you solder it all together. But otherwise, it's a fairly simple assembly on a perf board. It doesn't take too long. You can probably wire this all up in an afternoon if you've got everything together, and then we can go and build the base and mount this onto it. Alright, now that we've finished constructing the module, it's time to focus on the base. Now in my case, I have to admit the base was a bit of an afterthought. I'd originally intended just to build the module and use it as it was, and use my own external power supply, and that's why I put the 3 terminals on it for connecting an external 3.3 or 5 volts to it. But when I put the module together and put it on my workbench, I found out it was a bit top heavy. The antenna on the front was literally pulling everything over and it wouldn't stay flat on the workbench, so it needed some form of a base. Now I originally thought, well, I'll just use a piece of wood for the base, but then I started thinking about building a base with a power supply, because as I said at the beginning of this video, there are a lot of times when you want to experiment with an ESP32-CAM, but you want to do the experiment in some remote location in your home, and it may be a location you don't even have easy access to electricity. So I found a small project enclosure in my collection of project enclosures. You can use a different box if you want. This one was about the right size. It could hold a 9-volt battery in it too, so I could build a small power supply out of it by putting in a little circuit card with some voltage regulators. And that's exactly what I did. I built a small power supply that supplies 3.3 and 5 volts. It can run off a 9-volt battery, and it can also run off an external power supply, and it allows me to send power over to this module. It also has a switch that allows me to cut the power to the module in case I want to use the FTDI power adapter instead. So let's take a look now at the construction of my power supply base. The power supply is based around 2 linear voltage regulator modules, a 5 volt and a 3.3 volt one. These modules are based on the AMS 1117 series of linear regulators, and they have a very simple pinout. These look identical, so make sure to make a mark on one so you can tell them apart. We'll need a couple of switches, an SPST switch for power on-off, and a DP/DT switch for the module power cutoff. You'll also need a power connector for the external power supply. I used a 2.1mm chassis-mounted power jack with an internal cutoff switch, which is a very common component. If your intended power supply module uses a different connector, you may substitute accordingly. However, note that this design requires a jack with a cutoff switch. We'll need a 9-volt battery and a suitable battery snap-on connector. Of course, you can use a different battery if you wish. It'll need to be a minimum of 7.5 volts and a maximum of 12 volts for best performance. We'll require 3 binding posts, preferably color-coded. And finally, we need a 3-pin female DuPont jack to connect to the ESP32-CAM Developer Module. We'll begin by connecting the negative battery wire to the switch connection on the power jack. Use an ohm meter with your power jack and test it with a 2.1mm plug if you're unsure of the pinouts. Connect the power plug ground connection to the ground connections on the inputs of both voltage regulator modules. Now connect the positive battery connection to the positive or tip connection on the power jack. Also connect the positive power connection to one side of the SPST power switch. Connect the other side of the SPST switch to the V-in connections on both regulator modules. Connect the V-out of the 5-volt regulator to the red binding post. Connect the V-out of the 3.3-volt regulator to the white binding post. Connect both regulator output grounds together, and then connect this to the black binding post. Now connect the positive 5-volt output to one outside pole of the DP/DT switch. Connect the positive 3.3-volt output to the adjacent pole on the switch. And finally, we need to hook up the module power cable. This is the one with the 3-pin female DuPont connector. Start by hooking the 5-volt wire on the outside end to the 5-volt center pole on the DP/DT switch. Connect the 3.3-volt wire to the other center pole. And finish wiring the power supply by connecting the ground or center wire to the output ground. Now here we have some of the components that we're going to use for the power supply base. The key components are these two regulators, and these are small regulator modules that just have 3-pin linear voltage regulators on them. There's nothing really special about them. And I went over this in a video that I did a while back about powering up your projects, and these were a couple of the modules that I looked at. Now they look identical, but one of them is a 3.3 volt and one is a 5 volt. And they're both very simple. They have two sets of pins. One set are the input voltage and one set is the output voltage, power and ground in both cases. So that's pretty easy to work with. Now you can use other voltage regulator modules if you'd like to. The principle is pretty well the same. Otherwise, I've got a 9-volt battery strap for my 9-volt battery, and I've got a couple of switches, a double pole double throw switch over here, and a SPST, a single pole single throw switch over here, and that's going to be the power switch. Now this is the jack that I'm using, the 2.1 millimeter jack for the power adapter. You'll notice it has 3 pins, and that's because the ground pin is switched. It can be switched between either the jack or the other terminal that's on here, and that's how we're going to connect the 9-volt battery, as you saw in the wiring diagram. So it's important again to remember that it's the negative side and not the positive side that is switched in this case. And I used a little bit more of this angled DuPont connector for the connections that I made on my little circuit board. I just used a scrap of perf board to wire this on, and that way I could make the connections for the inputs and outputs really easy, and I could disconnect them if I wanted to. And I'll show you how I did this. Now this is the little case that I have. Obviously if you're using a different case you'll need to assemble it slightly differently, but as you can see I wired everything onto a board over here. I've got my 9-volt battery there. This is just a scrap of perf board that I inserted in the slots here, and I notched it out so the wires could go through it, so it both holds the wires in place and also holds my 9-volt battery in place. You can see my switches, my DP-DT switch, my single pole switch for the power, and here's my power jack over here. Now on the board here you see I mounted my regulators facing downwards so that the actual voltage regulators themselves are facing toward the board. What I did is I made sure that I spaced them quite a bit so that it has a lot of room for air to flow. And another thing I did is I drilled a couple of holes over here, and these holes are right above where the voltage regulator on this module are, so it gives it some more place for the heat to dissipate. And even further on my case I also drilled 2 holes because these holes are going to end up underneath the test module, and so you're not going to see them anyway, but it just gives the heat a little bit more area to dissipate. And as you can see I've got the DuPont connectors on here, so all my connections to the board, the 2 wires coming in for the input power, and then 2 outputs, one output going to the 3 binding posts that I have here, and the other output that goes to the DP-DT switch and then out through the other connector that I have fed up the top over here, and that will also connect to the module. Now you'll notice I put 4 spacers on here so I can hold my module on top of everything, and basically that's it. You can see the layout here. All we need to do is put the module on top of this and test it out and see if everything works properly. Now it's a good idea to give your power supply a final test before you hook it up to the module, so we're going to do exactly that. I've got a 12-volt power adapter over here, and I'm going to plug it into my supply. I'm going to switch it to the on position that I've marked off with this little red dot, and we'll go to our output over here, which should have some output. That's the ground there. And this should be about 5 volts, and 4.995 volts is pretty darn close. And this should be 3.3 volts, 3.285 volts. That's pretty close as well. Now let's see if our internal battery's working. We'll unplug that. We should still have the same outputs over here. And 4.998 volts, that's pretty close to 5. 3.286 volts, so that's pretty close to 3.3 volts, so that seems to be working. One final test we can do, we'll just turn it off for a second here. We'll connect, I've only got the bottom card of the ESP32-CAM experimenter's board here. I don't have the board with the cam on it, just in case there's something wrong. I'm going to connect this to its DuPont connector, and we'll turn the power back on. Now, in this particular case, this switch over here, being out here, should not be feeding the power to the board, and so I'll just measure that to confirm that I shouldn't have anything here. Here's the ground, and no, I don't have anything there or there. But now I'll throw this switch over here, and that should change. I should have an output over here, and there's my 5 volts, my 4.998, and an output here is my 3.3 volts. So that all seems to be wired correctly. I can go and mount these on permanently, and then we can give this whole assembly a test. Okay, our module is all built, and all that remains is to test it out. So let's hook it up to a computer. We'll bring up the Arduino IDE. We'll run a demo sketch on the module, and then we'll disconnect everything to make certain that our portable power supply is functioning properly. So let's get to it. And so here's our completely wired up and running ESP32-CAM module. Now I've got it connected to my computer with an FTDI adapter through a USB cable with a mini USB connector on the other end. And right now the module is powering everything right now. I've got the power switch off right now, so I'm using the power from the module. And I've got the module strap for 3.3 volts as well as the strap on the board for 3.3 volts. Now I have already programmed the ESP32-CAM module just with the demo sketch, the same sketch that I used the last time that I looked at the camera module. And in order to program it, I used this jumper here. I had to move it into the forward position during programming, and then after programming I could move it back and I could reset it. Now before we take a look at the operation of the ESP32-CAM, let's take a look quickly at this LED and push button that we've wired onto the board, and we'll try them out. Now we should have 3.3 volts over here coming from the module, so I'll take 3.3 volts and feed it onto this terminal, which is the LED positive. And I'll take a ground connection from the center thing here and feed that onto the LED's negative side. And as you can see, our LED is lit up, so our LED is working. Now we can also test the push button switch. Let's move the negative to one of the pins on the push button, and we'll connect the LED negative to the other pin. So in other words, we've put the push button in series, and now when I press the button, lo and behold, we have a working push button and a working LED. So our little peripherals here seem to be working fine. Now let's go and check out the ESP32-CAM that I'm running off of the FTDI adapter power right now. Now, if you take a look at my serial monitor, you'll notice that I'm running into a condition that I've run into many times with the ESP32-CAM, and that is that I have a brownout detection. And this happens because there's not enough power being delivered through the FTDI module in order to power the ESP32-CAM. Now, one solution that I've used before has been to use a USB powered hub in series with this, like before the FTDI module, and that'll usually give it enough juice. But right now I have another solution, and that's to use my internal power supply. So I've already got this switch facing forward. Let's put the power on, and we'll take a look at our serial monitor, and now it says that the Wi-Fi is connected, and it's given us an IP address. So the power supply that we've built has enough current in order to start the radio and get the Wi-Fi working. You'll find that situation a lot with Wi-Fi and Bluetooth. So what we need to do is we need to highlight and then do a Control-C on that one, and then go into a web browser and paste that address in there, and I'll just refresh that because I had that there before. And here is our ESP32 control panel that's being broadcast. So we'll start the stream to take a look at our image, and we get a beautiful image that appears to be sideways, and that is the development flaw that I was telling you about. My camera module here should really be mounted sideways. If I were to turn it sideways, then I think you'd see that we have an actual proper picture over here. And so now, of course, we are running this still connected to the computer. Before we go back and disconnect it and run it on its own, let's just go back to the serial monitor over here. And if you can see, the serial monitor is actually showing what the performance of the camera is, and it's actually not too bad. 24-25 frames per second is a pretty good rate, actually. And so what I'm going to do right now is I'm going to just go back to this screen, and we're going to disconnect this, and we should still have a working camera, because we are now battery powered, and a working sideways camera that we can move around the workshop a bit and take a look at the tools over here and take a look at the drill press and some of the equipment over here. We're getting this effect on the video, by the way, I suspect because of the LED lighting over here. This 60 Hertz is beating against it, so that's common under fluorescent and LED lights. And it seems like our portable camera is working just fine. And we'll put it back down here on the bench and get our sideways picture. And so there you go. Our ESP32 camera development module is working and ready for doing all sorts of ESP32-CAM experiments. And so there you go. We have a working ESP32-CAM development module all set for doing all these wonderful ESP32-CAM experiments. And you'll be seeing many more of those experiments very soon here in the DroneBot workshop. Now, as I said at the beginning of the video, you don't need to necessarily construct something like this just for the ESP32-CAM. You could do it for another microcontroller or microcomputer, such as the Arduino Pro Mini or maybe the Raspberry Pi 0W. They could use the same principles. The power supply alone could make a very good project for those of you who need a small portable power supply. It's a very simple construction and it works quite well. And of course there are improvements upon my design that I'm sure you could make. You could make a printed circuit board instead of using the perf board. You could take the module and rebuild the front module. In fact, I might do that to mount it sideways so the picture comes right side up. There's a lot of room for improvement, but what I really wanted to show you today was how I constructed a small project, because you can use those same principles for constructing projects of your own. Now, if you want some more information on today's project, you want to get the schematics or a few more details, there is an accompanying article to this video on the dronebotworkshop.com website, and you'll find a link to that article right below this. While you're on the website, consider signing up for the newsletter as well. I send out a newsletter now and then just to let people know what's going on here in the workshop and keep them up to date. It's not a sales letter or anything. I'd love to have you as a subscriber. Speaking of subscribers, if you're not a subscriber to the YouTube channel, well, please go and honor me by subscribing. Just click that little subscribe button and also click the bell notification so that you're aware every time I make new videos, and those will be new videos on the ESP32-CAM and a number of other great electronic devices. And if you like electronic devices, you can also go over and visit the DroneBot Workshop forum. We've got a bunch of great people who love to talk about electronics, and if you're having a problem with one of your projects, or if you'd like to help somebody else out, it's a great place to be. So until the next time we get together, please take good care of yourself, please stay safe, and we will see you again very soon here in the DroneBot Workshop. Goodbye for now.